This is Intro to Proofs, section 4.3. We're doing preview activity 3. So in this preview activity, we're being asked to do a table for, a truth table for this statement. So I've already done, we normally do the first variable, all trues and then all falses, and then 2 trues, 2 falses, and then ultimately true, false, true, false. That helps us get all possibilities, which are 8. So now, let's do this. So X implies Y. So whenever Y is true, that's going to be true. I'm going to do those first. And here, this will be false because X is true, but Y is false. And here, X is false, so it becomes vacuously true. Okay, now Y implies Z. So that'll be true whenever Z is true. And then here, Y is true. Here, Y is false. Here, Y is true. Here, Y is false. All right, so now let's AND those together. True, true, false, false, true, 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 false. Okay. And then X implies Z. So this will be true whenever Z is true. So true, 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 true. And then it's going to be false when X is true and Z is false. Here and here. And then vacuously true here and here. Okay, so then the implication, it's going to be, this implication will be true whenever the conclusion is true. And here, when it's false, X implies Z is false. But the AND is true, so I'll make this false. And then here, that makes it true, it's vacuously true. But hold everything. I'm not sure about this one. So X implies Y, and Y implies Z, so X implies Y. Y implies Z here would be false. Did I mess up anywhere else? False, 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 true, false, that makes this false. And here's Y implies Z is true, 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 false, true, false, false, true, false, false. That's actually true. No, that must have been looking at the wrong ones here. Okay, true, 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 true is true, true, false is false, false, true is true, false, false is true. And then ANDing them together gives me true there, and true, false here, and true, false here, and false here, and false here, and true there. And then this gives me, so false, false is true, and then false, true is true, false, false is true, true, true is true, false, true is true, 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 true. And so here, notice that these are always true, which makes this, remember the word? It is a tautology. All right. So now, move this out of the way. And that means that we have these statements here, which are, there we go. Assume that we have 3 statements that are true. We have P to Q, Q to R, and R to P. Okay? Explain why each of the following statements are true. A, P if and only if Q. Okay, so why does Q imply P? Well, Q implies R, and Q implies P. Therefore, using the thing we just showed, Q implies P. And the other 3 are just the same. Let's do them just because we were in classroom now. We've had you guys do them. Q if only if R. Well, we have Q implies R, so we need the R implies Q. So we have R implies P, and we have P implies Q. So thus, the statement P implies R. R implies Q is true. Okay, and then C. R if and only if P. Well, let's see, we already have R implies P. So then we need P implies R. So we have P implies Q, and we have Q implies R. So that gives us that P implies R. Okay, now what we did here was really important because it saves us a lot of time with a particular type of statement. So let's say we had a proof where we wanted to say that three things are equivalent. So basically we're saying, to say three things are equivalent is like this statement, and this statement, and this statement. So all you need to show is that like the first one implies the second implies the third, and the third implies the first. And that shows that all three statements are equivalent. So it saves you like half the time to know this sort of logical equivalence. So this finishes preview activity 3.